Inter-VLAN routing, the topology, okay, iOS layer 2, a Linux container for a PC, I need okay, I will add 7 interfaces. Okay, between DLS1 and DLS2, facetnet 1 and 12, I would use instead 1.1 and 1.2. Between DLS1 and ALS1, 7 and 8, instead I will use gigabit 01 and 02. Between DLS2 and ALS1, 7 and 8, okay, 01 and 02 in my case. Between ALS1 and DLS2, 9 and 10. Okay, I will choose 03 and 10, 03 and 10. Okay, DLS1, DLS2, ALS1, ALS2. Okay, more PCs. Okay, more Linux containers. Okay, choose a name. Good night, and all PCs are connected to fast Ethernet 6. Okay, I will connect to gigabit 1.3 in all cases. To create the username and password for each PC, I need to build the initial configurations. Okay, ready, and launch simulation. Yes. Okay, all devices in green. Configure multi-layer switching using distribution layer switches. Load base config. Use the reset TCL script you created in lab 1, preparing the switch to set your switches up for this lab. Then load the file base.cfg into the running config with the command copy flash base.cfg to running config. This is the example for DLS1. Use the TCL shell to run this script and load this file to the running config. All this to erase and configure the basic settings on all the devices. Also, verify the switch management database configuration. For example, at each switch, use the show SDN preferred command to verify the appropriate template is chosen. The DLC switches should be using the dual IPv4 and IPv6 routing template, and the ALS switches should be using the LAN-based routing template. If any of the switches are using the wrong template, make the necessary change and reboot the switch with reload command. For example, on ALS1 on a real switch 2960, for example, ALS1 show SDN preferred is the default template. Configure terminal and set the SDN preferred to LAN-based routing. And for DLS switches, layer 3 switches, choose the dual IPv4 and IPv6 routing. Then reload. System configuration has been modified. Save, yes, and reload. And confirm, press enter. Okay, this is not supported by VIRL or GNS3, so I will do the following. Okay, this is the script for the TCL shell. This for configure the basic settings. Okay, this script create this file base.cfg that you can load to the running config. Or simply you can use these commands. I prefer to copy and paste these commands to the devices. But before to apply the basic settings, you need to run this script to erase the device or execute these commands. For example, this is for layer 3 switches that erase the device and set the SDN preferred. And this is the script in the commands for a layer 2 switch. Erase the device and set the SDN preferred. Okay, but I said the SDN preferred is not supported on VIRL, so I will modify this a little bit. Only remove the SDN preferred configuration. Okay, the blank line is an enter key to confirm. Apply all this on the devices to erase the contents for layer 3 and layer 2. Layer 3 and layer 2 switches. Okay, DLS1, console ports, enter, enable, Cisco, and apply this. Okay, is reloading, DLS2, enter, enable Cisco, DLS1, enter, 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 enable Cisco, DLS2, enter, enable Cisco, paste. Okay, and now configure basic settings. Look at the range of interfaces from 01 to 03 and 10 to 13 in all devices. Okay, for basic settings, include the 00, 01 to 03 and 10 to 13. Okay, and shut down all interfaces. Set the domain name, not domain lookup, BTP mode transparent, the line console, no exit timeout, and login synchronous, very useful, exit and set the host name according to the topology. Okay, DLS1, enter. Okay, enable, configure terminal. DLS1, DLS2, enter, enter, enable, configure terminal. Okay, DLS2, ALS1, enter, enable, configure terminal, paste, ALS1, ALS2, enter, enable, configure terminal, paste, ALS2. Configure layer 3 interfaces on DLS switches. Enable IP routing, create broadcast domains, VLANs, and configure the DLS switches with the layer 3 interfaces and addresses shown. Okay, DLS1, for example, VLAN 99, and use this IP address on the interface. Also, on DLS1, create a loopback interface number 1 with this IP address. This is the example for DLS2. On DLS2, you need to create two VLANs, 110 and 120, with IP addresses and also a loopback number 1 with IP address. Enable IP routing, create VLAN, set a name, and configure the IP addresses on interfaces. Okay, I will start with DLS2, the example. IP routing, VLAN 110, name management, exit, VLAN 120, name local, exit, interface, VLAN 110, IP address, this IP 10.1, 110.1, subnet mask 24, not shut down, exit, interface, VLAN 120, set this IP address 10.1.120.1, subnet mask 24, no shutdown, exit. Finally, loopback number 1, interface, loopback number 1, IP address, subnet mask 24. A shutdown, exit. Okay, DLS1. Okay, on DLS1, loopback 1, and VLAN 99. DLS1. But first of all, enable IP routing. Okay, create VLAN 99, VLAN 99, name, set the name. Okay, any name, for example, support, exit, interface, VLAN 99, IP address, use this IP 10.199.1, subnet mask 24, no shutdown, exit, and finally loopback number 1, interface, loopback number 1, IP address, subnet mask 24. No shutdown, exit. At this point, basic inter-VLAN routing can be demonstrated using an attached host. Host D is attached to DLS2 via interface facet 6, in my case gigabit 13. On DLS2, assign interface facet 6 to VLAN 110 and configure the host with the address 10.1.110.50 subnet mask 24 and the default gateway of 10.1.110.1. Once you have done that, try it and ping loopback 1's IP address 192.168.1.1. This should work just like a hardware router. This should provide connectivity between two directly connected interfaces. Input below The switchboard host macro was used to quickly configure interface for Ethernet 6, in my case gigabit 13, with host relative commands. Configure the interface with these commands. DLS2 interface gigabit 13. Switch port host. Okay. Mode access, port fast enabled, channel group disabled. Assign this to VLAN 110. Switch port access VLAN 110. And now shutdown command to enable the interface, then exit. Configure the host with this IP address 10.1.110.50. Yes. Cisco. Configure Ethernet 1 sudo ifconfig Ethernet 1 with the IP address this password Cisco and the subnet mask 24. Okay, verify ifconfig Ethernet 1, this IP, and this subnet mask. And the default gateway 10.1.110.1. Okay, verify the current default gateway IP route. This is the default via current default gateway. First of all, remove this. Okay, remove this. Okay, verify. Okay, now default via and add the new sudo IP route. Add default via ready. Verify. Success. Default via using Ethernet 1. Ping loopback 1's IP address 192.168.1.1. Success. Control C to stop. Configure layer 3 ether channel between DLS1 and DLS2. You will interconnect a multi-layer switches in preparation to demonstrate other routing capabilities. Configure layer 3 ether channel between DLS switches. This will provide benefit of increased available bandwidth between the two multi-layer switches. To convert the links from layer 2 to layer 3, issue the no switch port command. Then combine interfaces 11 and 12, in my case gigabit 11 and gigabit 12, into a single port aggregation protocol ether channel, and then assign an IP address as shown. DLS1 the first IP in the subnet, and DLS2 the second IP in the subnet. This is the example for DLS1. No switch port, create the ether channel with port aggregation protocol with the desirable keyword, enable the interface, enter to port channel number 2, and set the IP addresses and now shut down. DLS1, for example, gigabit 11 and 12. Interface range gigabit 11, 12. No switch port. Okay, no switch port to enable the layer 3 channel group number 2. Okay, number 2 mode desirable. Okay, no shutdown to enable the interfaces. Exit. Enter to interface port channel number 2 and set the IP address. The first IP on the subnet. Okay, first IP on this subnet mask 30. No shutdown. Then exit. Configure DLS2. The same process. Gigabit 11 and 12. No switch port. Channel group 2 mode desirable. No shutdown. Exit. Interface port channel 2. Set the second IP in the subnet. No shutdown. Exit. Now on DLS2, for example, and to verify the ether channel, show ether channel summary. Okay, R and U uppercase are a layer 3 ether channel, and U in use. P uppercase bundled in a port channel. Group 2 port aggregation protocol. Finally, you can pick the interface in the another side. Success. On DLS1 and pick the another side interface. Success. Configure the default routing between DLS switches. At this point, local routing is supported at each distribution layer switch. Now to provide reachability across the layer 3 ether channel trunk, configure fully qualified static default routes on DLS1 and DLS2 that point to each other. For example, on DLS1, configure the default static route and set the exit interface port channel 2. But also, you can use the NetHop IP address. For example, on DLS1, configure terminal IP route, default static route. Exit interface port channel number 2. And the NetHop IP address is the IP address on DLS2 on the layer 3 link. This. And on DLS2, configure terminal IP route. The exit interface port channel 2 and the NetHop IP address. Okay, for example, on DLS2 verify show IP route. This is the static route. And from DLS2, you will be able to ping loopback interface on DLS1, 172.16.11. Success. And from DLS1, you will be able to ping loopback interface on DLS2, 192.168.11. And ping. Success. Configure remaining Ether channels for the topology. Configure the remaining Ether channel links as layer 2 port aggregation trunks using VLAN 1 as the native VLAN. For example, ALS1, fast Ethernet 7 and 8, in my case gigabit 01 and gigabit 02. Channel number 1 connected to DLS1, fast Ethernet 7 and 8, in my case gigabit 01 and gigabit 02. And VLANs allowed, all VLANs allowed except 110. Okay, this link between ALS1 and DLS1. Okay, this link using gigabit 01 and gigabit 02. Port channel number 1, layer 2 Ether channel. Okay, use port aggregation protocol. Okay, for example, on DLS1, configure terminal interface range gigabit 01 and gigabit 02. Switch port mode trunk. Okay, first of all, in this case, configure the encapsulation, because this is a layer 3 switch. Okay, switch port trunk encapsulation .1Q, and then configure switch port mode trunk. Okay, switch port trunk allowed all VLANs except 110, and create the channel group number 1. This channel. Okay, channel group 1 mode desirable to set the port aggregation protocol. Okay, group. Okay, enable the interfaces, not shut down. Exit. And use the same process on ALS1, the another side. Interface range gigabit 01 and 02. Okay, ready. And to verify, show Ether channel summary. Okay, S for layer 2. Okay, U in use, P for bundle in a port channel, port aggregation protocol. Now configure on the connection between ALS1 and DLS2 using fast Ethernet 9 and 10, in my case gigabit 03 and 10, channel number 4 connected to DLS2 9 and 10, in my case gigabit 03 and 10, and only allow VLAN 110. Okay, configure this. Between ALS1 and DLS2, port channel number 4. Okay, port channel number 4 and layer 2. Okay, go to DLS2, configure terminal, interface range, gigabit 03 and gigabit 10. Okay, 03 and 10. Switch port, trunk, encapsulation, .1q, switch port, mode trunk, switch port, trunk, allow it VLAN 110, only allow VLAN 110, and channel group 4 mode desirable, no shutdown, exit. The same process on ALS1, configure terminal, interface range, gigabit 03, gigabit 10, switch port, trunk, encapsulation, .1q, switch port, mode trunk, switch port, trunk, allow it VLAN 110, channel group number 4 mode desirable. Okay, no shutdown, exit. Okay, and verify, show ether channel summary. Okay, number 4, for channel 4, layer 2 in use, port aggregation protocol bundle in a port channel. Finally, configure the connection between ALS2 and DLS2 using fast Ethernet 7 and 8, in my case gigabit 01 and 02, channel number 3, DLS2 interfaces gigabit, in my case gigabit 01 and 02, permit all VLANs. Okay, this link between DLS2 and ALS2. Okay, port channel number 3, layer 2. Okay, first of all on DLS2, interface range, gigabit 01 and 2. And the encapsulation, mode trunk, allow it VLAN all, the channel group is number 3. No shutdown, then exit. ALS2, interface range, gigabit 01 and 2, Okay, the same process here. Okay, verify and show the third channel summary. Okay, layer 2 in use port aggregation protocol group 3 bundle in a port channel. Okay, also you can use show interface trunk. Okay, look at port channel 3 is the trunking interface. ALS1 show interface trunk. Port channel 1 and 4 trunking interfaces. DLS2 and show interface trunk. 3 and 4 trunking interfaces. Very good, because port channel 2 is layer 3, okay, and DLS1 and show interface trunk. Port channel 1 trunking interface. Very good. Enable and verify layer 3 connectivity across the network. In this step, we will enable basic connectivity from the management VLANs on both sides of the network. Create management VLANs 99 and at ALS1 and 120 at ALS2. Configure interface VLAN 99 at ALS1 and interface VLAN 120 at ALS2. Assign addresses referred to the diagram and default gateways at DLS1 and DLS2 respectively. Okay, this is the example for ALS2. Create VLAN 120, set the name, assign IP address not shut down, and the default gateway will be the IP address on DLS2. Okay, for example, on ALS2, configure terminal VLAN 120, name management, exit, set the IP address interface VLAN 120, IP address. Okay, this IP address for VLAN 120, 10.1, 120, 224. Now shut down, exit, and set the default gateway IP default gateway DLS2 on VLAN 20, 10.1, 120.1. Okay, and the same way on ALS1, but use VLAN 99. Okay, ALS1, configure terminal, VLAN 99. I use the name support, exit, assign the IP address, VLAN 99, IP address. Use this IP 10.199.2, subnet mask 24, no shutdown. Finally, the IP default gateway will be the VLAN 99 on DLS1 10.199.1. Exit IP default gateway. And okay, for example, go to ALS2 and ping from ALS2 to DLS2. The VLAN 120 on DLS2 10.120.1. Okay, ping 10.1 then that 120.1. Okay, success. The default gateway of DLS2. Now try to ping now loopback 1 on DLS2. 192.168.1.1. Okay, and if ping fails, try again. Okay, configure terminal IP routing, enable IP routing, now disable IP routing. Okay, and ping again, and now it's success. Okay, for example, ping the layer 3 interface on DLS2. Okay, okay, it should be 16, 172.16. Okay, success. The same process on ALS1. Ping the default gateway VLAN 99 on DLS1 10.199.1. Success. Configure terminal, enable IP routing, disable IP routing, no IP routing, and ping loopback 1 on DLS1, ping 172.16.1.1. Success. Ping layer 3 interface on DLS1, success. Ping layer 3 interface on DLS2. Okay, success. And ping ALS2 VLAN 20 on ALS2 10.1.120.2. Success. Okay, and from ALS2 ping ALS1. 99.2. Success. Okay, for example, use trace route Okay, the first hop is DLS2, the second hop is DLS1, and the third hop is ALS1. Try trace routes on ALS1 to reach ALS2. First hop is DLS1, second hop DLS2, and third hop ALS2. Configure multi-layer switching at ALS1. At this point, all routing is going through the DLS switches, and the port channel between ALS1 and DLS2 is not passing anything but control traffic, BPDUs, etc. The Cisco 2960 Layer 2 switch is able to support basic routing when it is using a LAN-based IOS. In this step, you will configure ALS1 to support multiple switch VLAN interfaces and configure it for basic static routing. The objectives on this step are: enable inter-VLAN routing between two VLANs locally at ALS1, enable IP routing, configure a static route for DLS2's loopback 1 network travel via port channel 4. Now configure additional VLANs and VLANs interfaces. At ALS1, create VLAN 100 and VLAN 110, and then create switch VLAN interfaces for those VLANs. Okay, configure all this on ALS1. Configure terminal. Enable IP routing. Okay, create VLAN 100. Okay, set the name local, exit VLAN 110. The name as internode, exit. Set the IP address on interface VLAN 100. Use this IP 10.1.101. Subnet mask 24. Now shut down. Exit. Set the IP address of VLAN 110. Use this IP 10.1.110.2. Interface VLAN 110. Set the IP address 10.1.110.2. Subnet mask 24. Not shut down. Oh no. The IP address not shut down. Exit. Okay. Configure and test host access. Assign interface for Ethernet 6, in my case gigabit 13, to VLAN 100. The attached host A, configure the IP address 10.1.150.24 with a default gateway 10.1.100.1. Once configured, try trace route from the host to 10.1.99.2 and observe the results. In the output below, the switchboard host macro was used to quickly configure interface gigabit 13, in my case with host relative comments. Okay, on ALS1. Okay, this is very simple. You will configure host A, and you will assign gigabit 13 on ALS1 to VLAN 100. Okay, and to go to ALS1, interface gigabit 13, switch port host assigned to VLAN 100, switch port access VLAN 100. Now shut down, exit. Okay, enter to host A, Cisco, sudo ifconfig ethernet1 on host A, set the IP address 10.1.150, 10.1.150, password Cisco, set the net mask 24, verify ifconfig. Okay, ethernet1 IP address and mask. Now configure this default gateway 10.1.101. Okay, verify the existing default. Is this? Remove this. Sudo IP root. Delete default via and add the new sudo IP root add 10.1.101. Okay, this. Okay, verify. Success. Okay, trace route from host to 10.1.99.2. Okay, ALS1. Okay, traceroute is not installed in this Linux container, but ping will work very well. Success. Control C. The output from the host shows that attempts to communicate with interface VLAN 99 at ALS1 were fulfilled locally and not sent to DLS1 for routing. Configure and verify static routing across the network. At this point, local routing at ALS1 works, and off-net routing outside of ALS1 will not work, because DLS1 doesn't have any knowledge of 10.1.100 subnet. In this step, you will configure routing on several different switches. At DLS1, configure a static route to 10.1.100.024 network via VLAN 99. Okay. DLS1, configure terminal IP route. The destination is this VLAN 10.1.100.024. Okay, and the exit interface for DLS1 will be VLAN 99, that is facing ALS1. Okay, very good. At DLS2, configure a static route to the 10.1.100.0.24 network via VLAN 110. Go to DLS2 IP route 10.1.100.0.24 using VLAN 110. VLAN 110 will connect from DLS2 to ALS1 using this port channel number 4. Okay? Because VLAN 110 exists on DLS2 and also exists on ALS1. And VLAN 110 doesn't exist on DLS1. Okay? The exit interface will be VLAN 110. Okay, IP route. Very good. At ALS1, configure a static route to the 192.168.10.24 network via VLAN 110. Okay, ALS1. IP route. The destination will be this subnet 192.168.10.24. The exit interface VLAN 110 because ALS1 will use VLAN 110 to connect DLS2 using this port channel number 4. And a default static route to use 10.1.99.1. IP route quad 0, and the exit interface will be VLAN 99 on DLS1 10.1.99.1. Very good. Okay, and verify show IP routes. Okay, ALS1 has a default static route, and ALS1 has 3 directly connected networks, 99, 100, and 110, and a static route to reach the 192.168.10 subnet. Okay, DLS1 and show IP routes. ALS1 other networks using port channel 2, the layer 3 interface connected to DLS2. A static route to reach the subnet 100 on ALS1, and 3 directly connected networks, 99, 72.16.10, the loopback interface, 172.16.12.0, the subnet to connect DLS2. DLS2 and show IP routes. Okay, a default static route connected to DLS1, a static route to reach the VLAN 100 on ALS1, and 4 directly connected networks, 110, 120, the subnet to connect DLS1, and the loopback interface, the local interface. Okay, go to LAS1, ping, for example, 10.1.122. Okay, from ALS1 ping ALS2. Success. Use trace route. Okay, the first hop is DLS1, second hop is DLS2, and third hop is ALS2. Okay. From ALS1 ping 182 and CTA11. Success. And try trace route. Okay, only one hop. This hop is the IP address of VLAN 110 on DLS2. So ALS1 is directly connected to DLS2. Okay, ALS1 is directly connected to DLS2. From host A, ping to LAS2. Success. Control-C to stop. Ping to loopback interface on DLS2. Success. End of lab. Save your configurations. The switches will be used as configured now for lab 5.2 DHCP.